In this video, we're going to dive into semantic data layers, what they are, and how it powers Orbital. So, a bit of background. Orbital is an integration platform. It connects your APIs, your Kafka topics, your databases, all of your systems together, building the integrations and pipelines for you. As things change, those integrations update automatically. So, instead of fixing broken integrations every time a schema shifts or a new system arrives, engineers stay focused on shipping features. Under the hood, this is powered by Orbital's Semantic Data Layer. Let's talk about what that means and how it works. A semantic layer is a shared vocabulary for your business. It's not naming convention or like a global domain model. It's metadata that defines what a customer is or how to calculate an account balance. It's the things that represent your business, but defined as standalone ideas. Then we map those ideas onto real systems, like your APIs, your event feeds, your tables, your files. And this lets tooling like Orbital know, hey, here's where to find customer balance. These two fields both contain customer ID. Now, here's why this matters. Let's say you want to stitch together some APIs or build a new data product, or maybe you want to enrich an event stream. Normally, you would start off by tracking down all the different systems, working out how to link them together, mapping fields, doing all sorts of busy work. When you're working with a semantic layer, you can skip all of that. You describe the data you need, and the semantic layer works out where it lives, how to join it, and how to deliver it. So there's no more remembering that customer ID in system A is the same thing as custref in system B. You just ask for customer, and the platform handles all the wiring. It's like giving your systems a shared language, so integrations become about intent and not about plumbing. Today, I'm going to show you all of this in a couple of different ways. First, let's explore the ideas behind this and how it works, and then I'll show it to you in action within Orbital. A semantic data layer is actually a really simple idea. It starts by defining terms that describe your business. For example, if we're a credit card company, we might have terms like card number or account balance. There's probably some customer information too, like customer ID and email address. So, before we go too much further, I want to introduce the technologies that we're going to be working with in this video. You've already heard me talk about Orbital, which is our integration platform. Orbital is actually built on two other pieces of technology, both of which are entirely open source. The first one is called Taxi, and Taxi is a language for defining your semantic layer. It's basically a type system for building semantics. The second is called TaxiQL, which is a technology for querying that semantic layer. TaxiQL is how we ask for data, and it's the engine that builds all of the integration. And these are the bits of technology that power the entire semantic layer of Orbital. It's entirely open source, it's up on GitHub, go and check it out. So once we've defined our terms, we can start adding them into our APIs and schema definitions. So here we have three different systems. We have a REST API that has information about our customers. We've got a SQL database that has information about our cards. And we've got an old SOAP API that has transaction data inside of it. And what we do is we can take those semantic terms that we defined and we can add them into our API definitions. So we can start off here by saying, hey, this field isn't just any old string, but it is an email address. And these two fields, even though they live in different systems and they have different field names, they are the same piece of information. They are a customer ID, and so on and so forth. Once we've done that, we can take those API specs with that metadata and we can publish them up to Orbital. And we can create this large graph of where all the data is and how it relates across the different systems in our enterprise. So when we get given a question like, hey, given this email address, what is the customer's account balance? We're going to need to orchestrate together three different systems to solve that problem. But because we have a semantic layer, we can do this without having to have first written any integration code or worry about how to connect the different systems together. Our semantic layer can work out that in order to go from email address to account balance, we first need to do a REST API call to swap the email address for a customer ID, and then do a database query to go from customer ID to card number, and then finally do a SOAP request to go from card number to account balance. And then we can work out that Jimmy has 29 quid in his account. Now we can do all of this without having first had to have done any integration between these systems. There's no glue code stitching them together. There's no GraphQL resolvers that we've had to build. It's just purely driven by our semantic layer. So not only do we not have to build any integration code up front, we also don't have to maintain or fix things when things change. For example, let's say that our cards team say that we're no longer allowed to go directly to the database and they're putting an API in front of it. So in version 2, our interface changes and we now have this cards API, a gRPC API that we need to talk to. And because it's a different interface, some of the field names are different. For example, customer ID becomes cardholder ID and card number becomes primary card ID. Now these are breaking changes. Normally you would have to go and repair the integration code. However, because we're using a semantic data layer, we can just take the updated API spec and publish it. The data layer can adapt, so we can see now that we can replace that database query with a gRPC call, and the integration repairs itself. There's no code that we have to go in and fix or repair. So all that's really left is how do we ask this question using our semantics? And that's where tools like TaxiQL can help. TaxiQL is a query language that lets us ask for data using the semantics of our business. So now that we understand the theory of how all this stuff works, let's jump into a real example. Now to do this, we're going to step out of the world of credit cards and we're going to look at a different demo, which is based in the world of films. Now, to start with, let's look at some code in Taxi. Remember, Taxi is the language that we use to build our semantic data layer. So here I am inside of VSCode, and you can see that I've got open a Taxi file where I've defined just some simple semantic types that I'm going to use to build up my semantic data layer. So all I've got is just these ideas that we come across when we're describing the world of films. We've got a film ID, a title, a description, a film review score of how good it is, some review text, and where people can watch it and how much it costs. Really simple stuff. We're not describing any systems here, just the fact that these ideas exist. And we've got some nice descriptions that attach to them. Here I also have an OpenAPI spec. And inside of the spec, I've actually embedded some of these ideas. So here is a REST endpoint that returns the streaming providers for a film. And you can see that one of the things that it takes as an input inside of the OpenAPI spec is the film ID. And this is a standard OpenAPI spec, but we've added in this metadata to say, hey, this doesn't just take any kind of integer, this takes a film ID. Likewise, in the data that comes out, it's got a couple of properties. One of them is a streaming provider name, and the other is the streaming provider price. So all we're doing is we're adding in this additional metadata into our OpenAPI spec. Now that we've done that, we can jump across into Orbital and start to browse how this stuff looks when it's inside the catalog. So here's Orbital's interface. If we take a look at, say, the review score. So here's that same type that I defined before in Taxi, shown up in Orbital's catalog. We can see here the idea of the film review score type exists as a concept, and we can click around and explore it. We can see that it's actually represented by the rating field on the film review data model. And if we click, we can see that that film review data model is returned by the film service. And it takes in a film ID and gives me back a film review. We can see the film ID is also present on the film review data product using the field name of movie ID. If we click to expand that out, we can see the film ID is a concept of its own, and it's actually used in a lot of places. So we can see that inside of here, already the semantic data layer is starting to get quite rich. So now that we've defined our semantic data layer, we're going to start writing some TaxiQL queries to ask Orbital to pull data from across our different services. So we'll start off by asking it nice and simple, so just grab a list of films. So here's our catalog of films. We've got a film ID, a title, a description, the year it was released, and a bunch of other stuff. That query itself is not particularly interesting. All we've done is Orbital's done is connected to a database and pulled back everything from the database. So let's tidy this up and ask Orbital to bring back the data that I care about. So we're going to define a data product. So find me the films, but give me the ID, the title, give me the review score, and finally give me the price. So when I run that, we can see the data coming back. This is using the data product that I've defined. What's a bit more interesting here though, is to understand how that query ran. So as before, we connected to the database to pull back our films information. But for our price data, we had to connect to a REST API to get the price from the streaming provider. And for the review score, we had to connect to a different API. Now, we didn't have to specify how to connect or which IDs to pass into these different services. The Semantic Data Layer is able to work that out for us. So now that we've done this, let's mess with it a little bit and break it. To do that, I'm going to jump into the code that runs my reviews service, my reviews API. So here it is. It's a pretty standard Spring Boot microservice that has a REST endpoint that takes a film ID and returns a film review. Now here, we're using some semantic metadata to say, hey, this doesn't just take any old integer, but it takes a film ID. So we're adding in that semantic metadata into our API spec, just like we did in the other version with OpenAPI. This time we're doing it directly in the code. So I'm going to change this to say, hey, we can't take just any old film ID. We actually get our reviews now from an external company called Squashed Tomatoes. So we need to take a Squashed Tomatoes film ID. It's still a film ID, but it's a different type. Likewise, down here in the data that we return, we no longer return the film ID. We're returning it now under a different name. Previously, it was called Movie ID. Now we're calling it Film ID. And the semantic data is different. It's a Squashed Tomatoes film ID. So this is a breaking change. Previously, the ID that came out of our database could be fed into this API. Now it's a different type of ID. So we're going to need to find somewhere across the enterprise to resolve those different IDs. So I'm going to redeploy my reviews API. We'll just restart the service. And if we jump back into Orbital, we can see that the schema has been updated. So when that service started up, it published its API definition up to Orbital. So we can see the old query plan here. To get our reviews service, we're getting data from the database, passing it into the reviews API to get our score. I'm just going to rerun the same query now. We can see that the same data is coming back. We can see that Academy Dinosaur has a review score of 2.7. But if I jump into the profiler and take a look at what's going on, we can see the query plan is different now. In order to get the score, we had to do this additional API hop. And that's because the Semantic Data Layer now understands that the ID that we feed into this review service is not the same as the ID that's coming out of the database. So it's made this additional API call to swap the ID that comes out of the database for the ID that's needed for the reviews API call. For my consumer though, nothing changed. Everything is still just the same as it was. We still get our data back and the query itself didn't need to update. So for the consumer, there's no breaking change, even though the entire infrastructure that's required to run this query has changed significantly. And that's the power of a semantic data layer in action. We're able to ask for data semantically and let the TaxiQL query engine work out where to source the data and how to stitch the different APIs and databases together, handling all of the mapping. And as our APIs changed, the integration adapted. Semantics are a really powerful tool for keeping your data sources decoupled and building self-healing integrations and data pipelines in record speed. The code for both Taxi and Orbital is all up on GitHub, so if you're interested in anything that you've seen today, head over to the repos, check them out, and be sure to give them a star. Thanks very much for watching.